So today's session is about media quality, call quality, and more specifically looking at the media quality in Skype for Business Online. My name is Sasha Juratovic. I'm a senior program manager in our Skype enterprise engineering team. I'm part of what we call customer engineering team, enterprise customer engineering team. And today with me I have Aaron Miller, and we are peers. We are working in the same team. Both of us, we have been focusing and working with a number of online customers as of lately, more specifically working with them to have really great call quality experience in their deployments. So let's have a look at the agenda very quickly. So this is what we are going to talk about in the next 75 minutes or so. So first of all, I'd like to give you a bit of an insight. Why should you really care? Why is this important? And specifically, if you are either already an online customer or planning to become one, and as you do that, if you are planning to do anything with real-time media. So after that, I'll be talking about call quality methodology, and I'll hand it over to Aaron after that, who will be talking about different connectivity options for the Skype for Business Online. We'll be talking about some recommended practices. We will show you some tools and resources that you would be able to use in order to apply those recommended practices. We'll have a couple of demos for you, and then we'll have a Q&A at the end of the session. So I'd like to ask you to refrain from the questions during the sessions. Would like to get through the whole content of the deck, of the presentation, and then we'll be more than happy to answer any questions that you might have. We'll be also standing at the booth, so we are kind of in and out at Skype for Business booth. So if you have, again, any questions you were not able to ask during or after the session, actually, feel free to come and ask us. We also have 5 shirts to give away, so at the end, if you stay at the end and ask the questions, if you have one of the first 5 who ask the questions, you will be getting these shirts as well, one of the shirts as well. So what should I really care, or why should you really care? So in order to kind of show you, and for you it's kind of not visualized because I won't be playing any video here, but you will be hearing a couple of audios here that would, I hope, give you an idea why should you care. There are a couple of things that might happen if you don't care, and I'll play first an audio that I have created or recorded and in kind of a clean environment. So both audios actually were taken in the lab environment. They were both peer-to-peer calls in my kind of a lab environment. The first one was in pristine conditions. There are no impairments introduced. So first you'll hear that one, and then I'll play you the next one, which I've kind of played with. As you can see from the slide, I have introduced some packet loss. So let's play that first, and hopefully you will see the difference.
Building this foundation, I'm happy to announce we will deliver 3 new services in Skype for Business. We will offer enterprise voice and audio conferencing in Office 365, starting with the technical preview in the US this summer, as well as enterprise-grade PSTN connectivity, beginning in the US later this year, followed by a global rollout.
Okay, so hopefully you agree it's a decent audio quality, no obvious kind of a robotic sound or breakups or anything like that. So let's play the second video and let's see what happens.
Building on this foundation, I'm happy to announce that we'll deliver 3 new services in Skype for Business. We'll offer enterprise voice and audio conferencing in Office 365, starting with a technical preview in the US this summer, as well as enterprise-grade PSTN connectivity beginning in the US this year, followed by global rollouts.
Okay, I hope the difference is obvious. And once again, what I've done, I have introduced 10% bursty packet loss when I was recording the second audio. Point also I would like to make on this slide is, as I was doing that, I was also doing mail, I was kind of browsing internet, and all of that was absolutely fine. I had no problems. And to be honest, I haven't noticed any difference. So, but that's your kind of a traditional data traffic, and for that traffic, you really wouldn't notice any major difference, even if you have, for example, 10% bursty packet loss. At the same time, you could really hear that when you play real-time media, which is audio, it's kind of annoying. It's not a good experience. So the bottom line is that the requirements for the two different data types is different. So it's something that you should be really kind of thinking of. And again, as you go maybe back 5 or 10 years ago, you didn't really probably think about the voice or the video on your network. So it maybe was not so important for you, and because of that, your networks have not been really designed with real-time media in mind. But as more and more actually customers and companies are adopting real-time media on their networks, this is becoming more and more important and something to think about. So let me kind of walk you through some of the reasons or some of the typical causes for the pain. So you've seen one, or you've heard one, which is the packet loss. There are a couple of others. So 3 typical root causes for the problems when it comes to the audio, for example, is latency, jitter, and a packet loss. So when it comes to the latency, it's kind of purely the time that takes a packet to reach a destination from the source. So, and you can measure it in a couple of different ways. You can measure it one way and a two-way. And typically you would find kind of a round trip numbers in the documentations. So that means that packet is being sent one way and then returned back to the source. So that's one, latency. The second cause is jitter. So latency, if you have a steady latency across the session, it might not, even if the latency is a bit higher than what you would want it to be, it might not be such a huge deal or a huge problem. However, when you have actually variation in that latency, so for example, some packets are received within a round trip for some packets is 300 milliseconds, and the next one is, I don't know, 350 or 400 milliseconds, and you have this kind of oscillation all the time, that is really bad. That is not typically good, and that would actually cause your users to experience poor audio. So jitter is the second one. And then the third one is the packet loss. And you've already heard the packet loss. It's essentially you send a packet from A to B, and some of those packets are not reaching the destination. Packet loss is, it depends actually on the pattern, on a frequency. Some packet loss, and actually it's kind of applicable for all of these. Some of these we can heal. So with our smart codecs, they can adopt, and actually they would be able to heal the traffic, and you wouldn't be hearing any difference. But for example, if you are experiencing a large packet loss, like percentage of the packet is 10% or even more, and even worse, if it's bursty, right, as opposed to happening every once in a while, if it's really bursty, in that case you would be losing chunks of audio, chunks of packet that represents the audio, and you would kind of, the receiver would simply hear drops or maybe robotic sound. So that's on the networking side. And then on the end user side, you have audio and video glitching. That's typically the problems that you would experience at the far end side. And these are caused by the user environment, which could be a system or devices. So when I say system, it could be operating system. It could be a faulty network card, for example. It could be drivers. It could be patches, things like that. When it comes to devices, a typical example is kind of a usage of the built-in speaker or microphone devices in your laptops, as opposed to usage of some qualified devices. Okay, so let's kind of switch the focus and say a few words about what are the good network characteristics, or what are the requirements for you to have a good experience when you have real-time media on a network? So first of all, you want to have consistent flow of the data packets. So nice and smooth, really. You want to have low latency, low jitter, and a packet loss. Kind of a self-explanatory, probably, and obvious. Randomness is not. Randomness can be compensated, as I said a moment ago, through some healing. However, some sequential loss is problematic. That's typically not a good thing. And as you go kind of a higher, as the latency, jitter, and packet loss are increasing, the possibility or the chances that the user would notice that is obviously greater. What about the bandwidth requirements? So we'll have a few slides later on that would kind of double click on some audio and some video requirements. But for now, maybe sufficient to say that there are, that depending on the codecs, for example, your network traffic would be consumed less or more. So for the audio, for example, as you can see from the slide, as low as 50 kilobits per second, as high as 220. And then a video has a similar, or, well, it has also some upper and lower bandwidth as well. Now, latency, jitter, and a packet loss. You can ask, okay, so great. I mean, I know these are the three things that can contribute to the poor streams, to the poor real-time media, but what are the kind of acceptable limits? What should be kind of an upper limit beyond where I shouldn't be really going because I would have really a bad experience? So these, you can see some numbers on a slide here. These are coming really from our experience, and they don't mean necessarily that if you go above them that the total call will be totally rubbish or poor. It just means that, hey, you should be really below these numbers, and if you are below this number, more than likely you will be okay. So for the latency, for the round trip, you should be really below 500 milliseconds. If you go to, I don't know, 510 or 520, you still might be okay. The other thing, which is actually a good point, speaking of the latency, why should you possibly taking some of these numbers with a pinch of salt? It could be also very much subjective to the users. So if you have users that are accustomed to, they already maybe have some VoIP over IP system, but they are really, the latency is, I don't know, 1,000 milliseconds or so, and it is what it is, right? There are some laws of physics that you can't do anything about, and they're already accustomed to some higher latency. They might be actually okay with that. So that's just another proof of point that 500 milliseconds is probably, for most of the users, something they should be striving to, but there are some exceptions maybe. For the jitter, it's below 30 milliseconds that you would like to be. And then for the packet loss, below 10%. And then more specifically, you don't want to have more than 3 consecutive packet losses. Because if you lose 3 consecutive packet losses, that's depending on kind of on a codec used, that can represent, I don't know, significant chunk of time that can, again, be on the far end heard as total drop of the packets. So not good. And then last but not least, UDP versus TCP. So for the media, for our media, we can do UDP or TCP. But the point here is that you should really be striving for the UDP. So you should be configuring your environment so the UDP is not blocked, for example, on the firewalls. And it's purely down to the transport, right? UDP is much more forgiving compared to the TCP when it comes to the real-time media. So how is this all relevant really to the Skype for Business Online? So first of all, you can go to the link that you can see in the first bullet point, which would kind of give you a Link Online service description. It's still kind of branded as Link Online, but it's obviously Skype for Business Online applicable as well. And the point here is that even today, if you decide, if you're already a Link Online customer or Skype for Business Online customer, or you're planning to become one in the future, you can do this today. And you can do essentially either conferencing or peer-to-peer, and you can do audio, video, and then application or desktop sharing. And all of these underlie, below all of these modalities, you would find real-time media. And then more is coming along the line, right? So you might have heard already on a few occasions this week, and it has been announced in March of this year. We are bringing some additional functionality, some additional features that, again, depend on the real-time media ultimately. So enterprise voice and audio conferencing in Office 365. We are planning for the US this summer. The second one is that we are planning to bring enterprise-grade PSTN connectivity and Office 365 or Azure Express route as well, coming later this year in Q3. And then there are some additional portfolio of meeting devices that we are also bringing to the market shortly as well. Things like Skype Room System, new Roundtable device, and Microsoft Surface Hub. Okay, so this slide is quite important in my mind. And why is that? So you can have the best media quality in the world, but media quality is just a part of a much bigger picture. Right? So you can see you have some success factors, you have almost some deployment preparations that you need to do. And only if you kind of go through all of that and do all of these, you are really standing a good chances for success, which would include ultimately a real good experience with the real-time media. So, for example, on the success factor side, what we are finding is, well, some of the really obvious things. We found strong executive sponsorship is quite critical for the successful deployments. And that's regardless of actually how you're doing deployment. By the way, this is also equally applicable for the on-prem as well. In fact, we have created this methodology or this way of thinking before we have actually started with the online. But this is equally applicable to both. So, and the way you can read this is kind of you look at a box, strong executive sponsorship, and then the idea is that the coloring represents how you're actually doing in a specific category. So this is an example, obviously, meaning that, hey, we are doing good, we are having actually a really good and strong executive sponsorship. Unlike, for example, robust devices strategy is currently in red because we have no idea or we have actually no plans in that area. So that's something that we need to improve on. So that's kind of on the success factor side. And you have similar on the deployment preparation side. Okay, let me switch the gears and talk about call quality methodology. So why is the quality a problem? So first of all, we are seeing substantial or quite a few customers actually opening a support cases and quoting a call quality as an issue for them. And essentially what we are finding is that as they are scaling out, they are having or hitting those problems. Typically, in a smaller or pilot deployments, it's not such a big issue because this is where you are normally kind of a testing functionality and you wouldn't be actually pushing the product and your infrastructure as far so that you can actually see all of these, for example, network issues. But then as they scale out, as they put additional users on a platform, this is when they actually start observing some quality issues. So what we have done, we have built this call quality methodology to really provide an insight into the problem. Okay? Now, CQM has been again designed for the on-premises in mind. Again, we have kind of started with that work a couple of years ago, and really our focus was on-premises customers at the time. However, the whole approach and methodology is equally applicable, or at least some parts are equally applicable to the online world as well. You would find, if you download, this is, by the way, it's coming as a package, it's coming as a zip file, you would find some documentation and you would find some tools. And then those tools are meant to be run against servers in on-premises environment. So you wouldn't be necessarily be able to use those tools in online environment against Skype for Business Online, but the methodology itself, the documentation is equally applicable and useful in online case. So why is it? Why we are finding actually customers struggling with this? Why is it so hard actually? So on the right-hand side, you can see a simplistic diagram, right? And it's to show that if a user coming as a remote user wants to join a conference, the user needs to traverse a number of components. So it maybe needs to go through the edge server before it hits AVMCU, where the conference is actually hosted. And there are obviously a number of points or number of components along the way, and any problem of any of these components along the way could have an impact on a whole conference. And then you have some users actually joining the call as dial-in users. They would be coming through the PSTN gateways over the mediation server, and again, maybe hitting AVMCU. So the point is that it's enough for at least one of these components to start introducing some impairments, so jitter, for example, or a packet loss, for either a part of the conference call, some users participating in a conference call, or possibly even worse, for all of the participants in a conference call to experience a poor audio quality. So the other thing that it's worthwhile saying is that some of these legs, call legs, is something that you can do about, and typically we call them managed networks. And then there are some components or some legs that you really can't do much about. So you kind of need to mitigate those cases, and then try to do something about the cases where you can influence. So a couple of good examples maybe for the managed networks. This is your typically LAN environment, right? Two users are trying to make peer-to-peer call. You would expect actually they're on a network, wired network as opposed to wireless maybe, you would expect those two users to have a really great experience. So that's an example of the managed kind of a network. On the flip side, you have maybe internet, or maybe you have some customers that are still considering wireless because simply they're coming from the times where the wireless has not been designed for the real-time media. And they might actually consider wireless as unmanaged as well. So these are kind of two different network types that we are introducing really in a CQM. And as I said, there are certain things that you can do something about, and there are some things that you really can't do much about. And this is especially maybe true for the online. And again, this slide is really, or the background behind this slide is coming from the on-prem world. So in the on-prem world, these are the three things, you're operating your service, these are the three things, or three kind of areas that you need to think about. However, when you are in Skype for Business Online, we are operating a service, right? So we are taking care of that. We are also operating the network between the servers in the data centers. So again, not something that you should be thinking about or you really can do anything about. It's our to think about those. However, at the same time, there are certainly some areas that you should be worrying about and you can do about. In the case of the network, it's going back to my example. You have two endpoints, peer-to-peer call. You really can control that, and you should ensure that there is a free media flow between these two endpoints. And then you have endpoints to the server. Well, this is kind of to an extent, and we will be talking about a bit Office 365 Express route, but obviously it depends on how you're connecting to the cloud. You might be actually controlling more or less this endpoint to the server connectivity. And then when it comes to the endpoint itself, this is absolutely something that can be under your control, and it should be under your control. So again, things like system devices, media transport, UDP versus TCP, and then media path, right? Media path meaning if I try to make a peer-to-peer call and there is a firewall in between blocking the traffic, well, I have to bounce through the relay or edge server. That's not good. More than likely, it's going to introduce some delay or some additional impairments. So with that, I'd like to hand it over to Aaron, who will talk about connecting to Skype for Business Online.
Thank you. All right, I'm on. Good. So I think the best part that leads into this section is where Sasha was just referring to the network piece on the previous slide, where we're talking about the connectivity between the endpoints or the buildings that you're working from to the online services. A context that I wanted to kind of outline first as we kind of go a little deeper into the context here is the idea of the types of connectivity that you can have. So right now, the primary connectivity that you can have to Skype for Business Online is going to be a public type of connectivity across the internet. And I've divided those into two contexts where we have consumer level service, which would be your home office and whatever ISP you may have there. And then your public hotspots or hotel Wi-Fi's, things like that, or even when you make your phone a hotspot or you have a MiFi device, things of that nature. Those are very consumer level services that provide you connectivity, sometimes really great connectivity. You can stream 4K Netflix over it or something like that. But it's not necessarily the same type of connectivity that you can get from a business level service that maybe you buy at an office building. So you're probably all familiar with a business class service where you have SLAs. If it's down, they ensure it's up. You can buy redundancy to make sure that if one line's down, you fail over. Or bigger pipes than maybe you can get from a consumer level service. All of those types of things. And then the best part, where you can get synchronous data rates as opposed to the asynchronous, which is much more common in the consumer level service. So all those things align. And the business side, you typically are going to see those where you're connecting your branch offices directly to the internet, obviously your main offices or central offices. And then at times you may actually be using that central office as the primary point to connect to the internet where your branches are coming out from there instead of going out on their own type of connection via MPLS or some sort of WAN hub spoke type of design. After public internet connection or a public type of connectivity, you have a private type of connectivity. And this is, I think Sasha alluded to it several times or mentioned it by name. And I know there's been several other sessions that'll talk about it or have talked or will talk about it. But now we're going to begin offering this express route to Office 365. So the idea here is that you're basically getting a private link to your tenant where you can eventually get into a situation where you can actually manage the content crossing that line. You can ensure some quality via packet marking. You can put in some flow controls to make sure that you're guaranteeing a class of service along that, such as GCAR. Those types of areas are going to provide you the ability to ensure a higher level or a more enterprise level of connectivity to that online service. So it's not always that cloud connection. We don't know what's going on there. We can't, or as Sasha mentioned, the unmanaged space. There is a future where there's a managed space for that service where things will be under your control, where you can actually have a say in the level of service or quality that you're getting there and impact it, which will be useful. So now that you kind of understand the ways you can connect, which are pretty self-evident, I agree, but you at least need to set the baseline. There's a couple areas, and this may not be totally legible. I know there's a lot of IP addresses and whatnot there, but there's a couple areas that you need to understand around the connectivity in general. It's not just enough to have a really big pipe. You need to make sure that the users can actually connect to the service. So a couple of points here. There's two sides, and this information is published via TechNet or various other places within the Microsoft site. It's very easy to Bing or use other search engines to find. And even on this deck, those titles at the top are hyperlinks to the information that I pulled a screenshot of to show you here. Some of it is variable, such as the IP addresses. Those may change, so that's something that you want to consider as you take a look at it. But the key point I want to make here is that there are various protocols, ports, and protocols such as UDP, TCP that we're transmitting over that you need to consider, making sure your clients can exit your network over those ports and protocols, as well as to various sites. Preferably, you can either let them go to anywhere, or if you need to restrict that, you can let them target the link.com space. If you need to restrict by IPs, that is something that they're providing that list for. But again, that's the one that's a little iffy because that may change. That's something that is as part of an online service as it grows and expands and things shift around. IP addresses fluctuate. So that's an area to be cautious about if you're hard coding external access over those IPs. Things that are more URL based are going to give you a lot more flexibility and not be restricted by those potential changes. So it's, again, important to make sure that the clients can get out to the internet, but it's also important to understand what the impact of the different connection types are. So, and this is really something that, and I'll talk about it later as we talk about some tools, but it's something that kind of leans towards training or adoption information for your users so that they understand the impacts of their choices. But it's also something that's good to plan for as you're looking and planning towards moving to an online service. This actually even applies to on-premises, so it's not purely an online consideration. But the idea that I'm trying to illustrate here with this very pretty graph that I made is to point out that depending on the endpoints, the position of those endpoints and their types of connectivity, you're going to have different levels or a different potential for a good experience. Obviously, moving from, I think this works, there we go, moving from the top left corner here in the dark green, that's going to be your best potential good experience, where both clients are wired networks on managed wired networks. Ideally, they're even on the same switch Not saying that has to happen, but clearly that's the most ideal type of connectivity you can get. Any other type of wired to wired over a good managed network, you should have a pretty fair experience. If you move out a little bit and you go to like a wireless connection, talking to a wired, an internal or managed wired connection, you'll see that it starts to kind of get a little lighter, moving towards this less potentially good connection color. The idea here is that wireless, you're not typically going to get the same experience. And even as we move to two wireless people talking together, it gets worse, right? Or potentially less good. The idea here is that wireless doesn't perform the same as wired. Even if you manage it really well, there's physics involved there. There's a lot of electromagnetic fields involved there. There's complicated factors that make wireless not perform quite as good, at least not yet, as wired. So in experience, this is a fairly reflective chart to the typical experience that users would have when one's talking to the other over these types of connections points. And clearly the worst being if you were both talking via Skype for Business client over two mobile endpoints, crossing a cellular data connection or mobile broadband as we call it. Those two connections, your bandwidth may vary. If you're on LTE, 4G, whatever type of connection you have in your countries, those things fluctuate from here to here as far as how much throughput you're getting. So you can see how that would cause a lot of variance in the quality of the communications you're getting. So again, just trying to point out that a lot of the decisions that people don't really realize they're making about, I'm just going to sit in my office for a few minutes and work on this, I'll stay on wireless, when they could dock or plug into a wire or something like that, can impact the level of experience you're getting. It doesn't mean it has to stay that way. There are ways to improve wireless quality and things like that, but there are clearly areas where you're going to have better potential for success than others. Okay, so the other area around connectivity is going to be your bandwidth planning. And I know this one's super fun, and it's a great chart to look at, right? Lots of numbers and information here, kilobits per second and good stuff. Some of you may be very familiar with it. There's a great list of codecs here where we're talking about the real-time audio and the G711 codec and how much bandwidth they transmit per second. This is very useful information. It's great for planning how much bandwidth you're going to use. You do some math and say, how many concurrent calls do I expect over a particular line? And then you multiply it by the kilobits per second, and then you have an estimation around how much bandwidth you can expect to see over that line during your average or peak usage, depending on how you've done that math. Then you get to do the same thing for video. And I know we haven't really talked about video. This is a media quality session. We talked a lot about audio stuff. Video is almost the same. There's obviously different factors in play, but where audio will have a breakdown, video will clearly have a breakdown. Audio is much more like you can almost think of a canary in the coal mine. If there's a line having a problem, audio is going to suffer. People will notice that before they notice video. They typically have a slightly higher threshold for video, jittering or glitching or having little artifacts in it than they do for audio being less good, because that means they can't understand you. If you look a little funny because your eye didn't move just right in that video frame, that's not quite as disrupting as they dropped a whole word out of your sentence and it changed the whole context and now they're angry at you. Right, so the audio is going to be a problem way before video is. So we spend a lot more time talking about audio quality. Video is still important, and video has its own bandwidth requirements. And as you can see, there's a lot of variables around what codecs are used and when, and there's sometimes two codecs used at the same time because we're splitting streams to talk to the MCU because he needs to send it to different types of endpoints. It's super fun and complicated. Luckily, you don't actually have to think about it too much. There is a tool that's publicly available. I'm actually going to pull up a version of it that's not quite publicly available, but you will have it soon, I hear. This one, did cut over, good. This one is geared towards online. So the current version of this bandwidth calculator is geared towards the on-premises world. There were ways that you could use it to kind of emulate and calculate that online space if you were really talented. They've made that a bit easier in this tool, so now it's something that you can use to plan your online bandwidth usage. So if you're looking at doing a hybrid deployment, an online-only deployment, or still on premises, then you can use this tool to help you gauge an expected amount of traffic over particular WAN segments, as well as analyze what you may need to do around QoS or guaranteed services and things of that nature. So I'm not going to spend a whole lot of time on it. I'm just going to kind of show you some highlights of how it's used. The idea here is that they have built a nice flowchart for you to kind of walk you through the tool. I've found in my experience that this is the most effective when it's used in collaboration with the network team, because there's a lot of technical information that's part of this planning around the line speeds between branch office and central sites, around the internet connection speeds, and which branch sites or central offices actually have internet connections. Understanding those things and how data routes in the network is kind of important when you're walking through this tool in order to make sure that you're doing the planning accurately. You can take a whack at it on your own, but until you run it by your network engineers and make sure that you're following, that your understanding is accurate, you're probably a little bit guessing, and you'd want to make sure that you're right before you move too far forward with recommending increasing lines and things like that. So here we see the flowchart starts us off. It tells us that we need to go to the sites section, and when we click these blue kind of buttony looking things, they actually are buttons. It will take us to the appropriate tab and walk us through it. There's a whole section down here below that is for more advanced settings. It allows you to change your personas, so you can have various personas. If you have coal miners that never use the product except for once a week or something like that, you can set them to very low requirements. If you have super high usage from your help desk, you can set them as a very high heavy user. If you have an executive level that you need to set up to make sure that you can separate them out as a specific class of service, you can assign that in there as well. There's also a usage model that you can configure around concurrency for conferencing, inter-office communications versus external communications, and so on. It's got a lot of bells and whistles, or switches and knobs, whichever analogy you like, that you can tune if you find you need to. But I recommend you usually start with kind of the default, go through it, see how it looks, see if it makes sense in your environment, and then if you need, go back and adjust those other areas to make sure that they fit your company or your needs. So I'll start off going through sites. Sorry, getting the mic there. So as we go through the sites, we see that it's already got some information in here, and this is actually the default. I was going to work up a whole scenario and go through it, but they actually have a pretty good one in there already. So this is the default as the tool comes down, kind of sample information that we see. So what they've done is they've set up a hybrid environment here. So we'll see that we have Office 365 running out of Amsterdam. We'll see that we have 4 central sites with a various number of users assigned to each one. We'll see that we have Office 365 associated to 2 of those sites where we're going to be using the hybrid type of connectivity, and that we have several branch offices, and we've defined which central sites those branch offices utilize. And we've even said that a couple of those branch offices are also using Office 365. Okay, so we've been able to now define our different central sites, our branch sites, the number of users at each one, how those interconnect, and then also which parts of my environment are using Office 365. It's not as granular as saying only half of this particular office is going to go to the cloud right now and so on, but it gives you an idea to start with as you play with those numbers to figure that stuff out moving forward. There are other ways that you can kind of look at that information, but right now it's kind of a office is online or it's not, and that's a pretty good start in order to get a feel for the type of bandwidth you're going to need. As we move over, there's a couple other fields I want to point out. I mentioned that you can modify the personas. The reason that's important is you can have up to 3 different types of personas involved in each site. So if you have a mixed type of workload or user type at your central office, if you have 5,000 people and 2,000 do this type of work and 3,000 do that type of work, you can split that up here because they potentially have significantly different load or usage requirements. And so it's important to define that so that you can understand what the impact is on your network. If you think everyone pretty much uses it the same, then you can just set up one profile. If you think that you have a good split in a field, then you can set up to 3 different profiles. All right, so once you've done that, you go back to start, and it takes you through and it kind of gives you some information about where to go next. This part about looking at the branches, I'm going to skip that for now because it's kind of a little farther down in the weeds. But as we want to see the results of what we've just looked at, we'll see that we start to see some good KPI information over here. So you'll notice, and I'll zoom in just to make it a little easier, you'll notice these are the central sites we referred to. And here we have a breakdown of the WAN speed that was reported, this coming again from a network engineer, the estimated amount of bandwidth for instant messaging, and it breaks down each modality along the way, whether it's conferencing or peer-to-peer, and so on. So it goes through audio, video, app sharing, if you're using enterprise voice, the PSTN load, and so on. And then we see it's estimating the amount of WAN traffic based on inter-office communications for that, for each of those branch sites. And you can see the second entry there is clearly overloaded, right? We have 290% roughly too much traffic going across that WAN. And then for the amount that they actually allocated to be dedicated to voice or real-time traffic, it's almost 1,000% over allocated. So clearly there's a problem. That site is in need of some additional work. And just for reference, that's London. As we, one other factor here, it also will break down for you the internet connectivity. So as you need to understand how much internet connectivity you can expect to see out of each site, this helps you understand that. So this being different than your WAN connection between offices, this would be what's traversing your internet, talking to people outside or going to the Office 365 space. So we see that information calculated as well, and again, broken down by the various areas. So a couple other tabs that it has, I'll just jump through real quick. A graph, this is largely showing you a lot of that same information that it had the KPIs for in the previous slide, but in a nice graph to show you. Again, we see London being oversubscribed. And then the deployment readiness is really the kind of bottom line. It's telling you whether you should move forward or not based on your network plan or your bandwidth plan. So this is indicating that you have quite a few sites that are ready to go, but there's about 3 or so that aren't and that you would have problems on, so that you need to address those. So it's giving you an idea of the overall readiness of your network and if it can handle the expected load of audio and video traffic. Very good. Great. And the remote. Okay. So a couple things that we see overall in the connectivity space around problems or areas that get us in trouble, or we'll just call them hurdles because that's what the slide says, are where there's no QoS strategy on the managed network for a corporation. So they're kind of just letting all data be data on the network and nothing's better than anything else, and it's first come, first serve. That's clearly a problem. Even if they have a QoS strategy, they don't track it, they don't ensure that it's deployed properly, they don't monitor it to make sure that it's not outmoded, so that they're looking for more bandwidth because the site's usage increased beyond their expectations. If they're meeting the peaks of the amount of data that they insured, then they're going to start potentially losing traffic, or if, depending on configuration, or at least putting it at best effort, which would make the users suffer. So if they're not monitoring it, that's almost as bad as not even having a plan. It's good to at least have a plan, but you got to kind of keep working that and make sure that it's working. Overall, network monitoring, if they're not tracking things like the bandwidth usage on their lines, between offices and the internet, things like that, clearly set up for disaster there. It's especially useful if they're tracking things like latency and if they can have any sort of voice detail there. And then deploying VPN without split tunnel. I know some customers, they just can't do split tunnel for whatever requirements, but every time you try to put voice over split tunnel, you're asking for problems. Are there scenarios where it works? Absolutely. People do it all the time and they don't complain. More often than not, however, people do complain when voice goes over VPN. And the worst part, when they connect or disconnect mid-call and VPN drops, or I'm sorry, the call drops because of the VPN change, cutting that connectivity. And then just not even having a knowledge of their network. Even worse than not having a QoS strategy or not monitoring is they don't even really know. They've just been connecting things and it all just works for now. If they haven't been planning or managing their network at all, they're set up for disaster. Deploying voice is probably not the last thing, but maybe second to last thing they should be doing until they get that sorted out. Okay, so with that, good step into some recommended practices with Sasha.
Okay, so what follows is a couple of busy slides, actually. They are really for your background information, so I won't be going through each and every of these bullet points, but on each slide I would like to kind of cover some of them. And most of those, I would say almost all of those, are really coming from our personal experience, by the way, working with those online customers we've done so far. So first thing I'd like to call out when it comes to the networking is perform network assessment. This is so critical. We are finding this extremely, extremely critical. Customers are making assumptions or they are thinking that the network is really in a good shape, and as they start actually deploying real-time media, they are finding that's really not the case. They are also kind of the line process is, well, it works for me for the kind of a mail, it works for the browsing, but again, it doesn't work. If you go back to one of the earlier slides, it doesn't necessarily mean it would work equally well for the real-time media. So they need to kind of, or customers, please kind of have that in mind as you are thinking of this. Aaron has already kind of talked about, I'd like to just highlight this. Customers deploying, for example, MPLS, we are finding, and we found it with quite a few customers, they simply, the MPLS network has not been, again, configured with real-time media in mind. And what it means is essentially they typically have some EF queues, and the traffic, they have so much traffic, the queues kind of fill up very quickly. But so the first problem is the queue is not deep enough. But the second problem is what we are finding is that once the threshold is being reached, the traffic, instead of being deprioritized, it's starting being dropped on the floor. So again, really not good. Consider, please, once Office 365 Express Route becomes reality in Q3 of this year, please start considering that as an option. We really would like your real-time media to get on our Express Route network as soon as possible, because on Express Route network we can really kind of guarantee some of the quality of experience. A couple of things related to the wireless. As you are thinking about wireless and start upgrading your wireless networks, please consider 5 gigahertz versus 2.4. I won't be drilling into the details, why is that, but sufficient to say that you would be better off normally with the 5 gigs. VPN. So Aaron has touched on that, so I'll simply skip that. The other thing that we are finding, actually, I've spoken on a few occasions with our support people, and funny enough, what they're telling me is related to the second to last bullet points. Customers are actually having these traffic shapers and WAN optimizers, and while those can work well for, again, non-real-time media, they typically, if not configured properly, would introduce problems for audio and video, for example. Then on the end-user environment side, so first of all, in the enterprise environment, you should definitely strive to use enterprise-grade equipment, not only as the infrastructure, so APs, for example, speaking of wireless, access points, wireless controllers, and all of this good stuff, but also on the devices side as well. On a wireless, what we are finding, for example, BOID, which is a huge trend at the moment, BOID can introduce a lot of complexity and a lot of issues for the wireless networks. Please use qualified phones and devices. You can find the link here. And then a couple of other things that we are seeing. We are seeing people, for example, when they are on the important calls at the same time, they are multitasking. We're all busy. They're multitasking. They are maybe processing a large spreadsheets, which is causing really a huge CPU usage. And that can actually impact the quality of the audio session. Please do the patching on a regular basis. If you are planning to share PowerPoints in your session, please use PowerPoint sharing instead of application and desktop sharing. Network consumption or bandwidth consumption for the former is much lower than for the latter. If you are finding yourself on a choppy network, meaning that you're in a session, all of a sudden you can hear stuttering, choppiness in audio, for example, you are having video enabled as well, start considering either first maybe reducing the screen size of your video, and if that doesn't help, maybe switch it off altogether. And then a few words about end-user training. So this is extremely important, end-user training. It's not sufficient that you optimize the environment and configure your environment properly. If your end users are not using the environment as you intend them to use the environment, well, I mean, it's not obviously good. So what are the things that, some of the things that you might actually consider as you are training your users? So first of all, use the best possible network connectivity. And Aaron actually had a whole slide on that. Wired is preferred, for example, over the wireless normally, typically, and that is preferred over the cellular. Then train your users to use fastest and shortest network path possible, meaning VPN, if they are, for example, in a hotel room or in a cafe, VPNing back into the network, unless it's really, really needed and mandated by the security, just to go out, again, through the corporate clouds, MPLS, and all of this goodness, to reach the internet normally introduces additional complexity, additional traffic, and impediments along the way. So, again, this is obviously very kind of specific to a different network, so just keep that in mind and train your users accordingly. And then Starbucks of the world are not best places to conduct your important meetings. This is, I think, quite self-explanatory. I'm just calling this out because, again, we know some cases where that happened. Wi-Fi quality typically in such environment is not adequate to have a real good audio or video calls. We have a tool, a PCD, and Aaron will touch on that in a moment, so I won't be covering that in any details here. And maybe I'll just close this slide with... So, for example, I'm finding myself in a hotel here in Chicago, and I was kind of looking at the network, and I couldn't even browse. I couldn't even send a mail that is kind of snappy. So the network is really bad, and you have to make the call. So what do? Well, if you are an online user and you are enabled for the ACP, audio conferencing provider, consider actually, instead of using a VoIP connectivity, consider using a mobile phone. That could be an option. It's not something that is obviously that you would maybe recommend to your users all the time, because normally or sometimes, it depends again, it can introduce additional costs. So this could be maybe a plan B that users should be aware of. So with that, I'll switch it over back to Aaron to talk about tools and resources.
Thank you. So, hello. So I think we've probably beat a little too much on the drama of you got to make sure the networks are under control. You got to monitor them. You have to make sure that you're tracking the usage and planning for it accordingly. But we haven't really said how we can help with that at all. So hopefully this next section will point a little bit of that out. The first thing is, and Sasha mentioned this just a moment ago, that end-user training is actually related to quality. So we typically think about quality being purely a empirical thing that we can track through reporting and network monitoring and the QoE reports, for those of you familiar with them in Link. So we typically think of quality as related to what we can really measure and analyze. But from an end-user point of view, we've learned that it's not always that. Sometimes it's about the fact that it's just hard for them to start a meeting because they don't really know how, or they weren't trained properly, or they forgot because they don't do it frequently. Or it's about, hey, sometimes when I join, I have to try twice. Why is that? So they don't understand. They're reporting to you an actual service level issue, a reliability problem that may be user training, but it could also be a systematic issue that's not straight related to quality as we would think about it. So keep in mind that there are some differences there. Here I've actually pulled out a tool that's available for you. It's updated for the Skype for Business client. There's an equivalent one for Link 2013 if you still have customers deploying that. Clearly, this is an online session, so they would be getting the Skype for Business client. But this has a lot of good content built into it, and specifically, it has several videos that are like little how-to videos for starting conferences. A lot of it is actually geared towards conference. I'm not sure why it's so heavily loaded that way. But it's still good information. There's several other like email like announcement templates that you can use to get people aware of what's going on, posters you can put around the office, and also some little quick start guides that the help desk can hand out, so people have a quick reference card on the desk, maybe after they do a PC refresh or the day after you cut everyone over to a new service. Somebody runs around and drops these on the desk, so users have some information referenceable. But again, all of that free. You can just go download it. It is like a 670 meg zip file, but once you get it, it's yours. Use it as you need for your company or for your customers and so on. All right, so that's kind of the soft side of it. Clearly, there's another side where we want to talk about the actual analytics part, the hard empirical piece. So for Office 365, there actually is a network analysis tool. What this does is it runs on your client, and we're going to do a demo of it here in just a few minutes. It actually runs on your client through a web browser, and it runs a battery of tests to analyze the network connectivity between that location and the Office 365 tenant to make sure that you can get connected in all the ways that you should, as well as that you have sufficient bandwidth. The other thing here is the pre-call diagnostic, or PCD as people call it. This is also a tool that you can use, again, on an endpoint, such as a Link or a Windows desktop. You can run it as a quick test, pre-call type of pre-conference. You have a really important call coming up. You can run it like for, I think it runs about 2 minutes in its quick test version to make sure that it's got good connectivity. There's actually a setting where you can just kind of let it run in the background if you're monitoring that network because people report hiccups around lunchtime or something like that. You can actually see if this experiences a problem and track some of those results. So that's a useful tool as well. All those hyperlinks are found in the deck, so as you get this deck afterwards, you can connect to any of those afterwards. A couple other tools. I know most of you should be really familiar with them, but just to kind of point them out, they do have a place to play here. They are useful troubleshooting and analysis tools, even for voice, which seems like a more complicated thing. It rides on the fundamentals of the network. So if you understand that the fundamentals of the network are good, then you should be seeing that any traffic across it is good. It's not guaranteed, but it's a great place to start. So Netmon, clearly there are other tools that do this as well, but actually capturing the packets and analyzing them using some sort of VoIP analysis tool to look at that information is a great way to get really detailed information. But at a lighter level, you have things like ping path or traceroute, which can show you, and there's a quick screenshot there, which can show you the route taken from that endpoint to where you're going. And I think I've referenced here the link online connection, right? The directory or the director that you'd be pointing at to make sure that you're getting there quickly, that you're not having a lot of latency somewhere in the path. And if you are, then you can try to identify that, or that you're even blocked from getting there for some reason if you're having an outage, so to speak. Oh, that's just the other tool. And then if you really, really are troubleshooting some quality issues and you really do need to know what's going on, the online service is asking your clients to capture a light level of logging. So it's that kind of default policy. Those of you familiar with Link on premises, you can control the policies that the clients default to and the level of detail captured. We're defaulting to light, and so you should be able to capture these logs from what's called the UCC API log. For those of you not familiar with it, that's just fancy speak for the Link client or Skype for Business client's log file. Inside of that, after each call, there's this VQ report, session report that gets submitted. And in it, you'll see a whole bunch of great data about that call. Even a trace route telling us the information that we just saw in that graph, or in that PowerShell, command line, that was telling us the latency between hops. This also will tell you things like the packet loss rate, the jitter, and so on with at a codec level of information to tell you what was going on audio-wise or quality-wise in that call. So there actually is, and I think, yep, I listed it in the bottom. I think he left already, but I'm pretty sure Aaron Steele wrote this blog, but it's a blog that tells you how to find this file, how to analyze it, and get this information. So it's easily searchable. It's also at the bottom of the slide. Quick little walkthrough on getting this information and how to look at it. Okay, so quick demo. Hopefully quick. So I did a little Martha Stewart. I already ran this demo earlier, actually on the Ignite Wi-Fi. So I was surprised with some of the results. We'll look at them in just a minute, but it was actually a lot better than I expected. While we're looking at that, I'm going to go ahead and tell this one to run side by side so we can kind of see it execute. So I'm going to go against our Contoso tenant here. And you can kind of watch it go through and do its spiffiness. So while it's running, and you'll kind of see it jump around and do stuff while we're working, but you'll see over here that this is the results. This is what we're going to find at the end when the other tool finishes. But basically, the results here are telling us that pretty much everything was great, except for the consistency of service. It had some problems getting to the end, and it says it's about 45%. So that's bad, right? Like that's pretty high failure rate. So otherwise, it didn't have a lot of packet loss. It had really good MOS scores. The capacity on the network was really good. So overall, this should be a great network. Clearly, there's some sort of like firewall level service or some sort of flipping within the network that's causing it to fail periodically for that consistency switch there. If we drill in, and I'll go back there for a moment, we can kind of look and see that it was doing some high-level checks here of the different types of connectivity, where it was showing us things like if it could do stun connections, HTTPS, and so on. There are a couple others in there that are good for the online service in general. They're not necessarily Link-specific or Skype for Business-specific tests, but they're good to know. And clearly, if it failed on SMTP, you would know that doesn't really matter for this client, right? As we move forward, we'll see this is actually one of the areas where it failed. So as we drill in here, we see that it was failing connecting to that endpoint. So it's telling us that the maximum hops were too much, and that maybe there's a firewall blocking our connection. Otherwise, it was really happy, but it had some problems getting to that other end. And so it was failing out. And there's a bunch of tabs. There's a whole lot of information available in here. And I'm not going to go through every little line of it with us. But I just want to point out that this is a tool available. You can test it against your tenant from a particular location. You can test it from various locations. Travel a bit, have fun, or ask users to run it if they're reporting problems with their online service to get information about what's going on in the network from their PCs or laptops' point of view. Just moving on. So this was pretty surprising. I don't know how many of you have been on the network. I assume everyone's phone is on the Wi-Fi and whatnot, but that throughput's pretty amazing considering usually you have trouble even getting your device connected to Wi-Fi. But yeah, I was pretty impressed with the speed that they're providing to you guys. You can see it's actually doing some VoIP-specific tests. So here it's measuring out some expected packet loss or jitter based on the performance of that network. So it's actually running a little VoIP simulation across that line and measuring the results, just like we do in real calls and real data. that you can look at, like I showed in that VQ reports, right? You can look at it as a simulated test here to understand what you should be seeing or what you possibly will see based on this scenario. A couple other factors, if I can zoom out. Round trip time, always important. Sasha mentioned kind of what those variables are. You know, we want to see less than 10% packet loss. We want to see less than 30% jitter. And then round trip time less than 300, 500? 500. I like to see it less than 100 because that means everything's great. But 500 is kind of that upper limit where things will start going bad. So let's see, where are we at here? You can see right now this guy over here is doing some capacity testing for the size. And you see we're starting to introduce some packet loss there in the bottom. When it's getting up to the higher speeds, it's starting to lose some packets. So a little bit after that, it'll stop and say, at this point, I started losing data, so it's no good. Oops. Let's see. And that's mostly it. Again, there's a whole lot of other interesting information in here where you can go through and look a lot more details that may or may not be interesting to you. Something that has fairly good results makes it a lot less interesting, unfortunately. If you had a lot of problems with packet loss and things like that, it'd be much more interesting to go in and look at some of these charts. And then, of course, the summary being the main thing. Let's see. Yeah, let's go ahead and cut over. I can cut back. You guys can see the results of this room running right now, if you like, at the end. And then I think we're moving. Oh, last bit. So there are several other sessions related, not necessarily directly to quality, but some of them do reference things such as the vital signs. That's more on-premises focused, but it's great information to understand kind of the standards we set. But various sessions that are important to understand about the future of the online service. The one that we didn't mention that was also probably a great use would be the Office 365 Express Route session, which will give you some more details about the roadmap and timelines for that so that you can have some understanding and planning there.
That session has happened yesterday, so go to the
Yeah,
website.
sorry, that was one of the last sessions yesterday.
Yep.
So, Q&A.
All right.
We have currently voice over IP, and we have quality of service based on VLAN. Our PBX is on a certain VLAN. How do you handle quality of service when it's an app
Can you switch back?
on a desktop?
Right, so the question was if you currently have VoIP deployed and you're using split VLANs in order to ensure quality or do quality over service on a separate VLAN, but then you move to something like Skype for Business where it's kind of data and voice on the same network, how do you manage that? And the quick answer is that within the clients, or within the OSs actually, there's the ability to tag packets for quality based on their modalities. So you can say this, the audio can be on particular ports, and when those ports are used, tag them for FE and make sure that they have the highest quality. I'm sorry, EF, the highest quality. So on Windows devices, you can do it with group policies. There are other
as well. So you do it either GPO way on a Windows client, or you do it by a port segregation on your network equipment.
Right. So yeah,
different people like different things.
Yeah, if you're not going to trust the endpoints to do it,
Yeah.
or you have various endpoints such as Mac clients where you can't control it as well, you can control the ports that are used per modality, audio, videos, and so on. And then you can use your network environment to say, when these ports are in use, it's because of these protocols, or when I'm going to these particular endpoints, it's for these protocols. Tag them as EF or 46, whatever, and get that priority. Let's see, right here in the middle, go up the line.
With Express Route, that's going to be published. I figure it's going to be data, they're going EF or QoS.
Mm-hmm.
What happens if data just tagging the person drop it, mark it?
So the question is, if you meet the cap for the amount of tagged packets, what happens to the max?
What if somebody fat fingers it and sending
The wrong marking?
DCP. Yeah.
Right, so if it's the wrong marking, then it wouldn't get into the right queue, right? So it wouldn't get prioritized. or it would fall into the appropriate queue for that marking. So that's typical reaction to that. And then as far as what happens if you max out, I'm uncertain, actually. It's a great question. Probably need to follow up with the Azure Express guys.
Yeah. I mean, you would talk to your network provider, right,
Yeah.
and negotiate that with them. And these are two very common problems that we are seeing.
Yes.
I was actually hinting early on MPLS how we are seeing different problems. One is actually misconfiguration end-to-end of the SCP. And I mean, you have to configure it properly, right? Either manually, in future we'll be getting SDN capabilities, so that's one thing. And then there is the other thing, this upper limit. Again, it is something at a moment that needs to be, you have to monitor it, you kind of benchmark, monitor it and see. I mean, if you go above it, negotiate with a network provider to actually up the limit.
Right, and there have been clients reporting that they maxed out and all of a sudden they start having huge packet loss. Well, it's because they're dropping it
yeah.
instead of doing best effort, right? So
Yeah,
they're guaranteeing that those packets fail. Sure you can, you just can't do anything else. Now let's go to the back.
We have some few.
So it depends.
That's a question.
But yeah, ideally you want to see anything above 3.6. 3.6 is considered good. Personally, I don't really complain until I hear it lower than 3, but that's just because I'm fairly tolerant. MOS, as you know, is kind of subjective. But yeah, 3.6 is kind of the standard we use to say anything lower than that is probably lesser than you would want.
And to be honest, when you're doing a really deep down investigation, when we do that, we don't look at that typically. It would be more jitter, it would be packet loss and latency. That's really what we are looking, all right?
Let's go over here, front row.
Can you guys talk about your architecture in terms of how Microsoft is using the Skype for Business? Like, how do you handle enterprise voice? I mean, there's no PSTN connection. It's on the way, but how do you handle it? Like Citron, you guys do you use, right? And when it comes to users, if your users are using like wireless or wired, if it's wireless, I mean, how do you handle these issues?
Right. Yeah, so the question is, how does Microsoft do it? And that's a great question, and there's a lot of detail to it. The quick answers are that we are on premises. The online part that's coming is being dog-fooded, so we are starting to use that and move portions of us to it. And the various other factors, such as, are we wireless or wired and so on, it's everything. You imagine it, we have that type of connectivity. And it's a bit unique because we have a fairly advanced user base, so they kind of know when they've caused their own problems and how to address it. But there are definitely office buildings that we've recently gone to and discussed. You're having a systematic level of quality problems. We've identified that the wireless is suffering here and we need to do something about it. Capacity-wise, configuration, whatnot. There's ongoing operations that manage and look into that, and that we try to maintain good quality on. Key to that is the CQM stuff Sasha discussed, where we're actually tracking and monitoring and making sure that we're achieving the right levels overall, and when there's problems, we drill into where those are so that we can go address them.
Do you actually use any third-party like SDN, like Aruba, how they control?
Yeah, I'm not certain.
Yeah, we do. We do. As we are doing development, we are actually working with our partners. SDN in itself, like when you install the agent on the front-end server, that needs to send some data, and it sends some data to the SDN controller. So as we actually work, we do actually work with our partners to help them really. It's kind of a joint development, if you would like. Yeah.
Sorry, I'm trying to spread the load here. Right here in the middle.
Is there a site how to learn Turkish with Snoopper in recording server?
I'm sorry, say one more time.
Is there a site how to troubleshoot with Snoopper in recording server?
There are various blogs about it, and then there's clearly TechNet. TechNet's not it doesn't do too much of a how-to use Snooper or the reports to analyze the information. I will say, again, to point to the CQM tool, that is something that goes through fairly detailed, and that's part of is it separate now? Or is it part of the networking guide still?
CQM?
Yeah.
It's still part of the networking guide.
Yeah, so there's a
In current
networking
release.
guide that's out there for the on-premises deployments that goes through a lot of details, but at the end there's the CQM section, which talks about how to review the data in your databases, what that means, and how to remediate a lot of it. And so that's probably a great place to start as far as doing how-to. As far as the snooper tool and things like that, mostly it's going to be blogs, and a lot of it has to do with kind of basic knowledge of SIP and real-time protocols to understand what it is you're looking at in those logs. Yeah.
So with respect to silk codec, given it's an adaptive codec, how do you estimate bandwidth? What's the recommended way?
Yeah, great question. I need to double check because I just got access to the new tool the other day, bandwidth calculator, but I'm not certain if they put silk in it yet or not. So that'll be a great thing for us to get to help do that. But the best way to do it is you can look at it in two ways, and I typically do all my bandwidth planning this way, where I look at the average to say we expect it to be about this, but then I do worst case peak planning. So I use the maximum amount of bandwidth that the codec can use and the maximum amount of usage and say worst case we would see this. And that includes using FEC, the forward error correction, and so on. So that gets big and ugly, but it's a great safety net to say, can we burst to this amount or not? And if not, where can we? How much of a difference is there, and so on.
Yeah, I mean, like for me, it's like that kind of makes sense, but because it's that adaptive, the whole purpose of that, if it senses that it's hitting the limit, it will now downgrade a lot of people, codec down to like midstream or whatever.
Potentially, yeah. And that's not new to Link or Skype for Business. The real-time audio codec did that as well. So it's something that's been experienced over time. What we found is that typically it's not so much of a once you hit a critical mass, everyone starts to suffer, as much as everyone starts to understand that there's some sort of quality problem and people kind of bail. They don't use the service as much. Not a great situation to be in, but that's where the monitoring comes in to be really important. Yep.
What would be a way to
No more shit.
apply POS policies to link devices like phone, desktop phone, or maybe
So how to deploy QoS to Link phones?
we can deploy to the endpoint with GPO, but you cannot apply GPO to the phone.
Right. So the Link Phone Edition actually can receive a command from the server that will tell it to enable the marking of packets and to what level to set that. The other method that aligns with all the other various clients is to use the setting of which ports to use per protocol, and then use your network devices to tag those packets. Because they're all capable of it. They can, assuming it's an intelligent enough device, but at a high enough level device, they can tag those packets based on the port usage and direction it's going and so on.
And you have that document on a Technet. If you search Technet for the Link quality of service, you would find all the documentation, what you need to do on the server side, what you need to do on the client side.
Yes.
Just what Aaron was saying.